So I think the hardest part for the probability test that you're going to take tomorrow is, believe it or not, just making a really good tree diagram, okay? Now, one of the things I want to talk about is you're going to have a homework question where they're going to say, these three different kids are trying to make a team. And this happens in high school all the time. People are like trying to make the basketball team or trying to make the soccer team or whatever, okay? Now, does me making the basketball team, let's say this is me, does that really affect you making the hockey team? Does that affect each other? No. But some people are like, but then you can't make a tree out of it. No, you can make a tree out of it. Just like if I had flipping a coin and rolling a die and trying to get like heads or tails on the coin and trying to get evens or odds on the die, they don't affect each other, but you can still make a tree for it. You get what I mean? Now, one thing that might be confusing to you is it doesn't matter which order you do this in then. If they don't affect each other, I could roll the die first and do the coin first. It doesn't matter. You would still have the same, let's look at it, outcomes, and there'd be 1, 2, 3, 4 outcomes that would happen. If I did the die first and then the coin, or the coin first and then the die, it doesn't matter because they don't affect each other. They are not dependent. All right, so you're going to have this question in your homework where three girls are trying to make the team. They're friends with each other, and then they're going to be like, what's the probability they all make the team? The only thing I can tell you is you do want to do the chart in this to make the key look right, like yours compared to the key. You want to start with the same thing they did. You get what I'm saying? Like, starting with the coin versus the die, the chart does look different. But at the end, the answers will be all there. They're just going to be in different places. Okay? So on that one problem where you have the friends that are all trying to make the team, just take a peek at the key so that you do the order of like who goes first, who goes second, and who goes third, the same as them, only because your answer will be easier to read off the key. All right, so now we are going to actually make one. And I want you to make a really good one here. And this is going to be for marbles coming out of a bag. We're going to have 3 black ones and 2 yellow ones. Okay, so 3 black, 2 yellow. Go ahead, sketch that. It'll just take you a second to actually make a little bag with marbles. Okay, 3 black ones, 2 yellow ones. Now, just, if you reach in and you grab it, isn't it a higher probability you're going to get red? No, sorry, not red, black. Isn't it just a higher probability you're going to get black? But what exactly is the probability you're going to get black? Well, it'd be 3 out of 5. That's really easy. Why do we even need a chart for this? The only time you'd need a chart for this is if you were going to grab in there twice. Because then it gets complicated. Like, what'd you get the first time? What'd you get the second time? And now on this kind, the order does matter. Unlike the team one, where you making the team doesn't really affect, as long as they're different teams, which they are, you making the soccer team does not affect Yolanda making the basketball team. They aren't, like, dependent on each other. Here it is, because if you get a black marble now, the probabilities just changed, because you keeping the black marble out means it's dependent. All right, so this is going to be dependent. You're going to remove and keep the marble that you get the first time. So that's going to affect how your chart goes. So now I'd like you to make the chart and make it very clear and clean and do every single branch of the tree. It really is easy if you've done all the parts, all the probabilities, and you've got decimals for all your answers. One more pro tip. Let's all do black first and then yellow, just so that your chart's easy to grade. Black, yellow, black, yellow, black, yellow. I know you would have had that part right. It's just if you had started with yellow, then everything would be upside down. Okay, so now your probabilities go on the branches. They go here and here and here and here and here and here. And then at the end, you need to sum it all up. Like this row right there, that's the black, then yellow row, and its answer is a decimal to 3 places. It is not 0.175 unless I'm the luckiest person in the world. Okay. But make something like that. Fill in all those little circles. I'm going to pause for a second while you make a really good tree diagram. Once you make the tree diagram and you do the whole thing, including these little summaries of like this row was, or this branch was black then yellow, then it'll be easy to answer the questions. Okay, I'm going to pause while you finish that out. So I'm going to record just so you can see how I got my final answers. What is 3/5 times 2/4? And I'm not going to have to say it again because it's the same exact thing. What is 2/5 times 3/4? And with all those 300s in a row, you might have been thinking, is the last one going to be 300 also? Is that even possible? No, because it has to add up to 100%. This last one, 2/5 times 1/4. I know it's going to come out to 0.1 because this has to add up to 100%. There we go. Now, if you make a chart that good, which you absolutely can, then the questions on these aren't hard at all. Like, for instance, if I say, given you got one yellow, what's the probability you got two yellows? That's like the hardest question I could ask. And it's not that hard. What does given mean again? What does that change? It changes the denominator. It changes what it's out of. See, what would it have been out of without a given? Well, it would have been all of these, which is out of 100% or 1. But since I said given we have a yellow, do you get, now we got it down to these three? That's what's possible. Given that, which the possible goes on the bottom, then what's the probability you got yellow, yellow? And if you're like, but I thought the probability of yellow, yellow was just this. It is. But given we got a yellow changes it from just 10% chance. If we know we got one yellow, then the probability of getting two just changed. That's why the given changes the bottom. All right. How many of you would have had 0.1 over 0.7? You get that. Okay, cool. All right. Now, let's say that the chart was even bigger. And you had all of these branches, 3, 6, 9. At the end, you had 9 choices. And it was about making or missing shots in basketball. Okay, you either make it or you miss it. Okay. And what's the probability that you would miss everything? Well, that would be like missing, 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 and at the end it's miss, miss, miss. And there's some probability of that, like, I don't know, only a 1% chance of that or something. If I asked you what's the probability of making at least one, do you want to add up all of those? Or do you just want to know what that last one is? All right, so I'm going to ask you this one more time. If this is miss, 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 what was the probability that you would make at least one? Don't say it. Talk to the kid next to you. What's the probability of making at least one? If there's a 1% chance that you're going to miss all 3 of them, the kid must be a really good free throw shooter. There's only a 1% chance that they're going to miss all 3. Okay? Then there's a 99% chance. See, all of these, they have to add up to 99. We can use the fact that they have to add up to 100. See, to not have to calculate all of those and add them all up. You get what I'm trying to say? You just have to know one of them, and then you can take 1 minus that. and you can get what all of these would add up to. All right, so let's do that on this scale. That was like me saying, make it about this question about the marbles. Okay, we're same exact problem we had. I'm just asking you a different question about it. What's the probability that you would not get 2 blacks? What's the probability you would not get 2 black marbles? Well, this is the 2 black marbles. So then, did you figure out it was 70%? Okay. Did you really add up this, and this? You probably just went, well, if it's not 0.3, it must be 1 minus that in your head. You probably just said, well, subtract off the 1 minus the 0.3, and then you get 70%. Okay, good enough on that. Next kind. You definitely have triple Venn diagrams. Please copy this down. It'll go fairly quick. Cat, dog, and mouse. And these are kids that have a cat, a dog, or a mouse as pets. Now, there was nobody who had just a mouse. 1 here and 1 here, and 2 in the middle. On the outside of this, which means they don't have a cat, a dog, or a mouse, there were 5 people out there. Now, I'll save you the time. This adds up to 14. So I'm going to put the 14 in the upper left corner of the box. You don't have to do that. That's not like a math law. It's just a smart idea to have the total up there. Okay, now here's the kind of questions you would have. You got some easy stuff, you got some hard stuff. Do you remember whether this is or and? Talk to the kid next to you. What does that mean? All right, good. Heard it from many, many kids. And the other one must be and. And so if I said cat, you, M for mouse, cat or mouse. Now notice I didn't say probability. I just said cat or mouse. That's a number. Figure out what the number is. Talk to the kid next to you. What do you think it is? 2, 3, 4, 5, 6. It is 6. All right. And how about cat intersect mouse? That does not mean or. That means and. Would you expect it to be bigger or smaller for an and answer? Smaller. And cat and mouse is not 1. It's a very common wrong answer. What is it? 3. Okay, and then we get into the conditional kind. Given blah, blah, blah. Now you might be like, we never divided by anything because they weren't probabilities before. So, given mouse, what's the probability of not dog? Given mouse, probability of not dog. Now, I know it's tricky, but start with the given. Given changes what's possible. Put the possible on the bottom. See if you can get it from there. It's a fraction. Your answer is like 7/5. Except that'd be impossible. All right. Not dog. Got to look at it and go, which of these people do not have a dog? Because those are the only people I can work with. All right. Talk to the kid next to you. What's your fraction? All right. Given mouse, would you agree I can only work with the people in the mouse area right there? So that adds up to 2, 3, 4 people. How many of you had a 4 on the bottom at least? Okay, good. Now, not dog. That messes people up a lot. I'm just going to go through and scribble off the ones I can't use. If it's not dog, I better not use any of those, because those all had dogs. So, of the ones I can use, only one I can use is that one right there. So it would have been 1 out of 4. Raise your hand if you had 1 out of 4. Nice. I know some of you are like, but what about the 5? Hopefully if you put the 5 there, you'd be like, it's impossible. 5 out of 4, that can't be a probability. So, all right. Now, the last melon. So, you either have a dog or you do not have a dog. You're either wearing a sweatshirt or you're not. You are somewhere on this chart. I want to just do a quick hands raised thing. I actually think it helps you understand these charts, and it makes it more interesting. So who's got a sweatshirt and a dog? You're wearing a sweatshirt and you have a dog. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, that's a lot. It's almost half the class. How about you're not wearing a sweatshirt, but you have a dog? 1, 2, 3 of you. All right. Who has a sweatshirt on, but does not have a dog? 1, 2, 3, 4. And who does not have a sweatshirt and does not have a dog? 1, just 1, 2. There we go. Okay. And then you can add them all up. That's going to be 16. That's going to be 6. That's going to be 17. That's going to be 5. But when you put them all together, it should be 22 either way. Are you with me on how I got the chart? Then here's an easy question. I'm not even going to have you write it down. It's so easy, but I'll start with an easy one. What's the probability that you don't have a dog? I grabbed a random person. Probability they do not have a dog. Should have been 5 out of 22. Raise your hand if you had that. All right, good. Now, given you don't have a dog, what's the probability that you have a sweatshirt? Given you don't have a dog, I'm getting somebody that does not have a dog. I'm going to choose only from them. What's the probability that you, did I say don't have a sweatshirt? No sweatshirt? All right, good. Okay. Given you don't have a dog, that was this. Automatically, if you don't have a dog, it was out of 6. Now, don't have a sweatshirt would be 2 out of the 6. Who had 2 out of the 6? Nice. All right, cool. I think you're ready as you can be. I'm warning you, the hardest question on the homework that you have, it's a review sheet. It's small enough, you can absolutely do the whole thing. I'm letting you start right now, and you'll have enough time easily to finish it. Walk out of here with no homework. It's pretty nice. But the one that's going to get you is the one about students making a team. You got to make a really good chart. And if I were you, I would just look at how they started, because you could start with any of the 3 students and just know which student to start with, but then make it yourself. You don't want to just copy the key over. You won't learn how to do it, and then you'll bomb. There's several questions about a chart. Several questions about making a tree diagram, and that tree diagram, if you just copy theirs, you won't practice it, and then that would suck. You might end up with a B or a C tomorrow, because there's a lot of tree diagram questions. Okay, so take that one very seriously, but peek at the key to see who goes first. All right, and that's all I've got for you for the video for today. And I'm